Hello everybody, this is Cold Wheels and welcome to the Beginner Programming for Hacking tutorials. In these tutorials we're going to go over 3 programming languages, Bash and Python and C in later tutorials. Bash seemed to me like the ideal selection to begin with since it's used a lot in hacking scripts along with the fact that it's quite easy relative to the other C family programming languages. Well, Bash stands as a piece of cake related to these languages, and it's quite strong when it comes to hacking, just like Python is. And, well, without further chit-chat, let's go open a terminal and cd to bash tutorials. And let's create our first script. Well, let me just make that full screen. Player. Well, the first program we're going to make in Bash is echo hi. This is Cold Wheels. And it says hi, this is Cold Wheels. Well, this program demonstrates 2 things. The first is echo prints out whatever it's given. So, hi, this is Cold Wheels. And the second thing is the terminal can also process Bash commands. Well, you don't need to write that in its own file and then write it in the terminal, just like, well, you can also see the idle in Python. Well, that may take a while to start up. And the terminal in Bash is just like the idle in Python, so that it can process any commands directly without having to write that in a script. Well, it seems like the idle is taking a lot of time to start up. And, well, we can drop to a Python idle here, and we can say print hello, this is Cold Wheels. So that's Python, and it prints out what it's given to. To exit out of that, you simply type Control D, or you can type quit, or I believe it's exit. I don't really remember that. Anyway, so the terminal processes Bash commands just like any other terminal, or just like any other IDE for the program processes, like for example the IRB. Let's take one final example. That's the Ruby shell, and if I say print, well, it's just like the Python syntax for printing, I mean, but the language is totally different. This is Cold Wheels, and it says hello, this is Cold Wheels, and it returns nil. Well, that's called return value for Ruby. That's another thing that we're not going to explain at all in these tutorials, and let's clear that. Well, if you prefer to write your own scripts in its own files, so we can say that nano, well, let's call that output. The extension, just like Python, is .py, and, well, let me write that here. For the Python, the extension of your files will be, for example, script name.py. For the Ruby, it would be, script name.rb. And for the C, well, that's pretty easy. It's script name.c. And that works the same for sh, sense, or bash. Well, the formal thing for bash is script name.bash. However, the more popular is .sh. You can choose whatever you like. If you want to prefer the formal way, it's .bash, and if you want to prefer the more popular way, it's .sh. Whatever you think. So we can say that, well, let's keep it .sh. And let's nano. The first program, we'll call it output, since it just outputs something to the screen. And let's call that .sh. And echo hi, this is Cold Wheels. But since this program is easy enough to write in a terminal, we're going to add another sentence, which is echo I like Bash scripting. And we Control X out of that. And let me make this one more time. To exit out of nano, you simply follow the instructions here, which is Control X to exit. And well, wait a minute. Nano. but we don't have to do this. And it says do you want to save the modified buffer, and we say Y for yes. And it says, well, what's the file name to write? Well, we already say that it's output.sh. To keep it the same, you just type enter. Well, pretty good. And let me, to of course execute that script in a terminal, you type sh output.sh. It says, hi, this is called Wheels and I like bash scripting. Now, to read the contents of a file, use the cat command to read it from the terminal. And it says cat output.sh, what's inside the output.sh files, and it shows what's inside it, which is what I wrote. Echo hi, this is called Wheels, and echo I like bash scripting. I'm actually gonna open up another terminal just to see the program and the explanation simultaneously. cd bash tutorials and nano output.sh. Oh, that's great. Let me make this hollows on top. There you go. Well, so in fact, when I typed echo, I used double quotations. If I do this in Python without the quotations, I get a syntax error. So would I get in Ruby. However, if I type here echo hi, this is called Wheels. It just outputs fine. And actually, these quotations have their more appropriate uses. For example, if I want to say echo the price is $2, and well, this will echo in a weird way, which is the price is nothing. So will it do if I use double quotations? The price is dollars. The output is just the same, and echo single quotations this time. The price is $2, and the program is fixed, and here you go, the price is $2. So this is related to something called the suppression of text inside the quotations, and this is outside our scope. Well, if I see a good time to explain it, I'll do it. Well, it's actually not outside the scope, since I'll explain already variables, and that was just to show that the single quotations and the double quotations have their more appropriate uses, and I can write these outside double quotations, but keeping them inside the double quotations is just as fine. Well, so that was for the first program. However, you notice that when we try to execute it, we always write sh output.sh. And it says, well, hi, this is called Wheels, I like bash scripting. Whenever you want to do a script, sh output.sh. And, well, in this case, you don't have to write sh output.sh every time, sh. You can just write /output.sh, which is the terminal way of executing a file. / and the name of the file. / and the name of the file. But before executing it, the terminal wants to know what is the programming language you're writing in. That's for one. And for two, you do not have executable permissions. In other words, you can't execute it because you do not have enough permissions to do that. And we're going to fix these problems with two commands. The first thing is, we're going to write here bin bash. And this means that, hey terminal, or hey whatever I'm writing in bash. Well, if you were writing in Python, you would have used user bin Python. And I believe if you're writing in Ruby, it's user bin and Ruby. So this tells the terminal, this is called a shebang. It tells the terminal, my friend, I'm writing in Python. My friend, I'm writing in Ruby. My man, I'm writing in bash. And this is it. So you don't have to write sh output.sh, since the terminal already knows that it's going to use the interpreter for the specified language. If it's Python, whenever you write /output.sh, it uses the Python interpreter. Sorry for that. Output.sh. There you go. And whenever you write .output for a Python script, well, or the script name .py, it uses the Python interpreter since you have included the shebang. It uses the Ruby for the Ruby files, and that's it. To save the file, you just also follow the instructions here, which is write out for save, and it's Control-O and enter. Well, but a new problem is posed, which is a permission denied. We don't have enough permissions for the output.sh to execute, and that problem we're going to fix with chmod 755 output.sh, and then we can run that output.sh and it says, hi, this is called wheels and like bash scripting. If we miss if we mess up with the terminal and we write user bin Python just for tricking him, and we say that this code is Python, my friend, so use the Python interpreter to decode it, we will have a problem, which is it's an invalid syntax. The Python interpreter just sees echo, hi, this is called wheels, and it says, what in the world is echo? And it's actually print in Python, so it doesn't interpret it, and it says that's wrong. If we use Ruby, it says that's an undefined method, echo. I don't know what echo means. However, if we use the correct shebang, and you always want to use that in bash, remember there's no user here, and it says, hi, this is called wheels and I like bash scripting. For further explanation of chmod, we're going to use a leaf pad, my trusty friend, and well, let's get a leaf pad here, and wow, failed to launch idle. Amazing. So I actually launched idle in the beginning of the tutorial, and now it says failed to launch. Well, thank you for the precious information, my friend. At least I'll not keep waiting. Anyway, so chmod, what it does is change permissions on or for a file or a directory. So what does this really mean? Well, in Linux, you know that you have to know that three things will access your file. First one is the user. Second is, wow, why did that happen? Second is the users group. And third is good. Others, who do not relate to the users group, not in the users group, and of course, obviously, they're not the user. And they can do three things to your file. So there are three things who will access your file, and three things they can do to your file. The first is read it. The second is write to it. And the third is execute it. And that, well, we're going to put read, write, wow, I have trouble writing today and speaking. Execute. Well, if you can read the file, then these are called 3 bits: the read bit, the write bit, and the execute bit. If you can read the file, in other words, you can see its contents just like we did with the cat command, well, the read is 1, it's turned on. If you can write to the file, in other words, you can modify its contents, delete it, move it from its directory, then you can write to the file and the write bit's turned on. If you can execute the file, in other words, just like what we did, /output.sh, then the execute bit is turned on. Well, this in binary translates to 1, 1, 1. And remember, the command we used for chmod was chmod 755. Script name is in binary translates to 7. So if you can read the file, you cannot write to the file. You can execute it, however. Then you can read it, see its contents, that's a 1. You cannot write to the file, you can't modify it, delete it, or modify its contents. Then the write is a 0, and the execute is 1, since you can execute that. And 1, 0, 1 translates into 5 in decimal. If you don't know how to change from, well, well, that's unfortunately outside your scope, so go search it on the internet. And it's actually quite easy. You can even use the binary converters, but however, I don't recommend that, since as a hacker, you need to know how to do the binary to decimal conversion and vice versa. Well, this explains the 755 in Chmod. Since the 755, well, the first one, the 7, is a 111. In other words, it's full. Have the 5, which is 101 in binary. In other words, you can read and execute. And finally, another 5, which is a 101. In other words, you can read and execute. But what does this mean? Well, 7 denotes the first thing, or the first person who will have the permission. So the 7 says that the first person will have a full permission, and the first person is the user. So you have full permissions over your file, and this is actually quite good, since you need to have full permissions over your file. You need to know how to execute it, you need to read it, and you need to write it and modify it if you want to. The second, which is the users group, have 5 permissions, which is read and execute. However, they can't write to the file, they can't modify its contents, delete it, move it from its directory, or even change permissions for it. And, well, the 5 denotes the others, so they also have read and execute permissions. And, well, this doesn't always work for every script. So, for example, if you want a highly secure script, a script that requests a password and has the password inside it, and then gives access depending on whether the password is good or not, valid or not, you need to chmod that, for example, 7, well, 1, so that the others have the read, write, and execute. The read, they can't read it. You don't want them to read its contents, otherwise they'll know the password. You don't want them to write to it, of course, and you want them to execute it, however, if they want to get access to a certain thing. So that translates into 001 in binary. That's 1 decimal, so 711 for the users group. If you want the users group to be able to read the password but they can't change it, so then you can change that into read and write. That becomes read 1 and write 0, and 1 execute. So that becomes, let me write that, read, write, execute. So that's 1, 0, 1. Sorry. And that translates into 6. So that's 761. In permissions, or in Linux form, which is 6 they can read and execute. However, they cannot write to it. They cannot change the passwords. They can read the file just to see what the password is, and they can execute it, of course. So that's it. You can change chmod to whatever suits your needs, and that explains chmodding and explains executing. So since the file is executable, ls, what it does is list the directories, or the contents of a directory. So since we are in bash tutorials, if we type ls, it says output.sh, and notice that output.sh is green. If I chmod that, well, obviously not. And well, I remove the executable permissions so that I can only read sorry, so that I can only read and write. Well, let me remove the output.sh and make it one more time, which is nano output.sh. Bin bash and echo. Hi, this is Cold Wheels, and echo. I like bash scripting. Sorry, scripting. Well, that's good. And I type ls, and it says output.sh, but this time it's a normal output.sh, not green. Green means that it's executable. So if I chmod 755 output.sh and I ls again, it says it's green so that I can execute it. And if I say ls-l, which is the long format for ls, it says that the user can, well, this means that it's not a directory since there's no D here. And the R means I can read, I can write, I can execute. The other, which is the users group, they can read and execute it. The others can read and execute it, and that's just what we explained. Let me put that here. Well, now we go into a more interesting example, which is nano name. Well, name output sh. We put the shebang. Yep, I believe it's working fine right now. And sorry, so I'm going to do this one more time. What I did is, well, let's control X out of that. rm name output.sh. And what I did is I said I want to create a more interesting example, which is name output. Sorry, but the mic just turned off, or I just accidentally unplugged the headphones, the headset. And let's say the shebang here, you always want that. And let's see, well, echo, sorry, please enter your name. And then we read name and we echo hi daughter name. Now this may seem weird at first glance, but let me chmod that name dot slash name output, and it says please enter your name, and I say this is called wheels, and it says hi called wheels. Well, there are three things to note here. The first is, well, you write your name on a different line, then echo prints the prompt statement on, and the read name, that's the second thing, not assume the echo dollar name. Now what's a dollar? And well, the first thing is easy. It's when echo, let me get that down. When I say echo hi, or please enter your name, in this case, please enter your name, and this is what happens. Please enter your name. And then there's a new line left here, so that anything that gets written after that is written in this new line, so that you don't have a chance of writing your name on the same the same prompt statement or in the same line. However, to suppress echo from printing this new line, we can use the dash n option, and we can go to the terminal and we say dot slash, you don't need to chmod it one more time, and it says please enter your name, and I say this is called wheels, and it says I called wheels. We suppressed echo from printing a new line by default using the dash n option. And now let's go to the read name. The read name, well, it takes an input, which is for example called wheels, and assigns it to name, which is a variable. So let me go here to the explanation. Explaining. Oh. Okay. And when we read a variable, for example, read name, this takes the input, assigns it to a variable which is namely name. So that name is a variable that has the value called wheels, or whatever you enter. For example, if you enter Joan, Martin, or anything, that gives you a read name, and it assigns the value of your input to the variable name. And last thing is echo dollar name. Now dollar means you are designing, or sorry, you're designating a variable here. So if you have instead typed hi name, then whatever your name was, whatever your name was, it would always echo hi name. So /name, please enter your name. My name is called Wheels, my friend, and it says hi name. Well, that's strange. And let me echo, well, my name is John, and it says hi name. Let me echo my name is Martin, and it says hi name. Let me echo my name is Hot Wheels instead of called Wheels. Maybe that will work, and of course it doesn't. It says hi name. So to tell the program that you are designating a variable here, you use the $sign. And this is why when we typed echo, the price is $2. It thought that 2 is, well, that has a special meaning, which is the command line argument, but it thought that this is the second command line argument, which is $2. And well, the second command line argument is nothing, since I didn't supply any command line arguments. So it says the price is nothing. And well, if I have used single quotations, then everything inside the single quotations will be treated as a normal text, and $name will be $name, not the name variable. And this is also quite bad, since if I, well, say cold wheels, what is that? It says hi name, and well, this is because I didn't say the file. Cold wheels, it says hi $name, and what is $name? And well, if I say my name is marked and it says hi $name, well, this is strange. So we're not using a single quotations here. This is when you want to really use the $sign as a $sign. You can also do that inside double quotations, but we're not going over that. Now let's go to a more interesting example, which is nano sum.sh. And in this case, we're going to make two variables and then echo -n. Please enter your well, that's please enter a number, and then read x. We will read a value and assign that to x. Echo -n. Please enter another number, and then we read y, and then echo the sum of your numbers is x plus y. That's everything. So which mod sum sh 755, don't forget the operand, the operator, and /sum with sh, and says please enter a number. That's 6 and 5. Wow. So that's 6 and 5, and that's 11. The well, that's not good. And the sum, and 74 and 26, that's 100, and it's working fine. Now this is all understandable, and this, well, except for the dollars and double parentheses, it's good. But let me explain that. Well, first, this is called a comment. Anything that begins with a hash is called a comment, and it's used there for only those who read, or those who are explaining them, but those who are explaining to them, and the interpreter ignores them. It says, oh, that's a hash and that's a comment, so I ignore them. It's not for me. So you can write whatever you like here, and nothing will ever happen. So, and it's a good practice to write comments in your code just so that it is understandable for others who are not reading or reading your code for the first time. And well, it doesn't matter how many hashes you write though. So explaining, and let's go to dollar double parentheses. Well, this is used for arithmetic operations. So 6 plus 5, that translates to 11. And if I typed 46 plus 30, well, that translates to 76. And this is called the arithmetic operations. So if I write here dollar, let's write that in a terminal just to be sure, and I'll have a problem though, which is 11 command not found. It thinks that 11 you mean a command by 11, but actually don't mean, you just mean to output 11, and in this case you're going to output or echo the sum of 6 plus 5, which is 11, and that's why we used echo here. The sum of your numbers is $x plus y. Now, to create variables, there are two things you can write to variables or make to variables when first declaring them. Well, let me get this straight. There are two things you can make to variables when first making them. So, first you can make a variable and not give it a value. This means declaring a variable. So when we made a variable x and y, this is nothing. We give them the value of nothing, so we are declaring x and y. But if we make a variable and give it a value, well, I missed an A here. Then this is called assigning. Did I write that right? Well, assigning variable. And here, to declare a variable in bash, you just type x equals or name equals, and it's nothing. X equals, or maybe its name equals nothing. You must also know that the space between, well, if we say name equals 6, then we made a variable and give it the value of 6, then this is assigning, not declaring a variable, because we made a variable and gave it a value. Well, you must also know that the space between the variable, the value, and the equal sign, there should be no spaces. This is mandatory. So if we type name equals 6, then this will result in an error, which is name command not found. So for example, if we say x equals 6, it would think that x is a command and it is not found. Sorry, there is no command by the name x. However, if we type name equals 6 without spaces, now this is legitimate. So there should be no spaces between the equal sign, variable, and the value. Okay, but here in the arithmetic operations, you can make as many spaces as you want, and it would not result in any problem. Actually, you can make that 6 space plus 5, 6 plus space 5, or 6 space plus space 5. Well, it doesn't really matter in arithmetic operations. And, well, this creates two variables so that I can read them by x and read them by y. However, you don't need to create a variable x and y. This was just for the sake of showing what declaring a variable is. Since read already makes a variable, when you say read x, or when you type read x and the user enters a number, if he enters 5, then read makes a variable x and assigns a value of 5. So this is called assigning a variable. It automatically does that. You don't need to create the variable first before reading it. So we can summarize the program, make it even shorter with removing the x and y. You don't need them. And another interesting function of read is it can prompt the statement before reading. So if I remove echo -m, please enter a number, and I say read -p, please enter a number using the -p option, enter a number, and then I of course write x and leave spaces here to tell it that after prompting the read statement, you read a variable and you read a value and assign it to x. Read -p, please enter another number. And if we see here, please enter a number, and you can even write it on the same line using the dash p option of read, so that's pretty interesting. 4 and 5 gives you 9, and here you go. So you read dash p prompt statement and then say what variable you want to assign the value to. So you don't need to declare the variables first, and that was just for the sake of declaring variables or showing what declaring variables is. Now let's go to a more interesting example, or a more powerful example, using branching, and we'll name this nano access.sh. Put the shebang here, echo, or now let's use read dash p, please enter a password, and after you read, assign that to password variable. And if the password, remember, you're using the dollar sign to designate variables. If password is equal to awesome, then echo, well, that's pretty secure password, access granted. Else echo, sorry, access denied. Try again next time. And phi. And well, that's chmod 755 access and dot slash access. And it says please enter a password. I say it's awesome, and it says access granted. And if I say any others, it would say access denied. And let me, okay, so let me go into explaining. To construct an if statement in bash, you use this expression, double brackets, the space is mandatory between your expression and the double brackets, expression, then you can omit the semicolon space then, and you can write then in a new line, but it's more popular to write a semicolon then, and then it's do some code, and the indentation here is not necessary, it's just for the readability of code. Well, else, if the expression is not true, then do something else. And this is what we did here. If $password equals awesome. Now this may seem strange since we say there are no spaces between the equal or the equal and the value and the variable. Well, this is because this is not the normal equal, but this is the comparison operator. The double equals means compare password to awesome, to the string awesome. If password is equal to the string awesome, then give the following, access granted. And the single equals means assign the password to awesome, and this doesn't work in the if statement. And well, the double equal sign is for comparison, so you always need to do that, or you can use the dash eq, which is also if the password equals awesome, but we're going to stick with the double equal sign. And you can do more things with the if statement, and this is just like the normal if conditional in English. For example, if it is 9 p.m. add as many else ifs as you want in an if statement, and the else if is written like that: elif some expression, then do, well, here we do some code in the if, and here of course we do something else, and in else we do the default. Well, if nothing of this works, we do the default. And let me explain that, or show that in the program, how we can insert an if here. So that's elif. Well, the password is awesome. We gave an access granted. Well, what if it's your... Well, here you go. What if it's your boss's password? So if the password is equal to great, and if this is your boss's password, please prompt him to change right now, or let him quit if you can. Echo hi boss. Since this will enter great, this is your boss, this is his password. So it says if password is awesome, echo access granted. Else, if the password is great, then echo hi boss. Else, well, it's nothing, it's not a valid password, and echo access denied. And if we try that, awesome, it's access granted, great is hi boss, and anything else is access denied. Well, what if there are two passwords that are valid? For example, if the password is awesome or the password is another password. Well, we can say if password is awesome or $password equals, well, security, another pretty secure password. But Bash has its own way of saying or. It doesn't really say or, it says the double sticks, or sometimes called double pipes. So it's double pipes for or, and it's a double ampersand for and. So if something and something, use the double ampersand. If something or something, use the double pipe, sorry. And if we try to execute this one more time, it says awesome. Sorry, I forgot to save that. Awesome. Well, sorry. Oh, come on. Awesome. And it says access granted. And security, it says access granted. So if the password is awesome or security. Now, if you are not the user, remember, you chmoded that 755 access.sh. That means that others can read and execute it. But if you only want them to execute it and not read it, to not know, because the password here, if they can read it, I can read that using cat. And it says, well, read -p, please enter a password, and if the password is awesome or security, then access granted, and if the password is great, then hi boss. That obviously leads to better privileges in hacking, and if you're a hacker, you think like this, it's, oh great, that's hi boss, so that leads to better privileges, so I'm going to use the password great. If it doesn't work, I still have two more passwords, which is awesome security, that will give an access granted. And being able to read such a script is really insecure, so we need to let the user be able to read it. However, those who are others, or even the users group, they will not be able to read it, and we're going to chmod the file 711, so they can only execute the file except the user who has full permissions. And access.sh and /access, still everything works as expected. Access granted, great, and security, it says access granted. Anything else is an access denied. And let me go into the last example of the tutorial, and this is the for loop. So nano, and let's say some math dot, I believe well, some math here, bin bash, and it says for number, well, let's call that n. Well, it doesn't really matter, that's a variable name anyway. You can name that whatever you want, as long as it's valid or it's legal. In dollar sequence 1 to 10, do echo $n done, which mod that 755. We can, well, 755, since there's no security here, there's nothing to worry about here. And /math.sh, and says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what this does is, well, explaining. First, to construct a for loop in bash, you say for variable in a list, semicolon, do, instead of semicolon then in if. And then you say, instead of phi, you say a done. You close an if statement with a phi, and that's the opposite of if, that's fi. That's how you close an if statement. However, in for, you close it with a done. And of course, you here do some code, and again, the indentation is just for readability. And do some code. Well, that's great. And why did we use the dollar sequence 1 to 10? Well, sequence 1 to 10 is a command, and it outputs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then dollar means perform that command first, what's in parentheses, and then act on it. And for n in sequence 1 to 10, that outputs a list from 1 to 10. For every iteration of 4, in the first iteration, take n equals 1. In the second, take n equals 2. In the third, take n equals 3. And for every iteration, when n equals 1, echo n, so that outputs 1. And when n equals 2, echo 2. Echo n again, so that equals 2. And notice here, I didn't even use any quotations. And then, well, for n equals 3, echo n. And until it reaches n equals 10, and it echoes n, so that gives you a 10. And then it's done, since there's no more there are no more elements in the list. It's only from 1 to 10, and once n it does not belong to the list anymore, the for loop quits and it's done. However, you also saw that sequence 1 to 10 just does what we did for the program for n and dollar sequence 1 to 10 do equal dollar n done. You can just write sequence 1 to 10 and output the numbers. So why the longer example? Well, the for can aid us in math. So if you want to, and let's use quotations here. For example, n squared, and asterisk asterisk means squared, or to the power of, and plus 41. And for every iteration in the first iteration, n is equal to 1, and this will be 1 squared plus 41, which is 42. And the second iteration, n will be equal to 2, and 2 squared is 4 plus 41, now that's a 45, and it goes on and on and on. So until n reaches 10, of course. And if we, /math.sh. Ouch. Now this is because I didn't put that in the arithmetic operation. And here you go, /math. And it's 42, 45, 50, 57 up to 141, which is 10 squared, and that's 100 plus 41, it's 141. So that's how a for loop might aid us in simple math. And another variation of the for loop is the while loop, and it's while a variable is in some value or has some value while something is true, do something. Or until something is not true, do something. So for example, until it is 7 p.m. keep exercising, and when it reaches 7 p.m. you stop. Or while 7 p.m. you keep exercising, and once it reaches 7 p.m. you stop. And there are many more branches in bash. For example, the switch case asec, and that's for example choosing between two results. And this is just like the if, but the if is used more for decision making. If the password is valid, access granted. If something is true, then do this. And well, this concludes our tutorial. Notice that we didn't do any examples in hacking, but and let me make sure that everything's fine, and that's good. So wait a minute, and here you go. So this shows that although we didn't do any examples in hacking, but the for loop is always used in hacking, the if is always used in hacking, reading, input, echoing something, this is always used in hacking, making variables. So although we didn't do anything for hacking, and we're going to do something in networking, you can consider that a spoiler, in the next tutorial using Python. So I hope everybody enjoyed this tutorial. bash programming using scripts and bash tools. Notice that we didn't go over many basic concepts here, like file or the grep tool or strings tool, and these may seem very basic to most programmers, but anyway, this was the beginning of what you need for hacking in bash. So again, if you didn't understand anything, you can comment. If you want to be personal, however, you can go to Martin, you can go to your inbox, email me at martinwelson5000@gmail.com. I hope you everybody have a nice day, and later.